We are going to look at piecewise functions. In particular, for this question, we are being asked to graph the function. But before we actually graph the function, let's talk about what the different parts mean and look at some specific values. So you'll notice that this particular function has three different pieces. So they're all defined in terms of your f of x. And on this first piece, it's telling us f of x is equal to 0 if your x is less than negative 6. Now, remember, f of x just represents the y value. So what the first piece is telling us is that if we look at certain ordered pairs where x is less than negative 6, so for example, negative 7 would be less than negative 6, that's telling you the y value would be 0. Pick another value less than negative 6, so let's say negative 8. That y value would be 0. And then another value less than negative 6, say negative 8.5. So they don't have to all be whole numbers as long as they're less than negative 6. So all of that would be points that represent that particular piece of the function. Now, on the second part, it is telling me that my y values are going to equal negative 2x if my x is greater than or equal to negative 6, but less than 0. So let's look at a few values there. So let's start with negative 6 since it actually says that my x can equal negative 6. So if x is negative 6 and you plug it into the function, negative 2 times negative 6 would give you positive 12. So that would be a point on that particular piece. Other x's that are greater than negative 6 but less than 0. So for example, we could pick negative 3, something like that. When I plug it in, negative 2 times negative 3 would give me positive 6. Something like, say, negative 1. When I plug it in, negative 1 times negative 2 would give me positive 2. Now, x does not equal 0 on that piece, but we're still going to plug it in because it means that the x approaches 0. It gets closer and closer and closer, but doesn't actually touch it. And the way we show that on an actual graph is you'll see an open circle. So we'll still plug it in. So when x is 0 and we plug it in, negative 2 times 0 would also give me 0. But we're going to make a special note that it should be an open point on that particular graph. All right, last but not least, we have a piece that says when your x's are greater than or equal to 0. And so that particular function is being defined as x squared. So again, let's look at particular points in this case. So we'll start with x being equal to 0 since it says it could equal on that part. When I plug it in, 0 squared would still give me 0. Now that would be a solid point, and we'll talk about what happens when you have an open point like we do from the second part of the function versus a solid. Other x's greater than 0, things like 1. So if I plug 1 in to the function, 1 squared would be 1. And things like 2. So when I plug 2 in, 2 squared would give me 4. Okay, so let's start looking at these particular points on the graph. So from the first piece, we saw we had negative 7, 0. Now keep in mind that those x's can still get smaller than even negative 7. We had negative 8, 0. So we're looking at things that are less than negative 6. We did negative 8.5, 0. Now we didn't actually plug in negative 6 there, but had we plugged in negative 6, then the y there would also be 0, and what we would see is we would see an open circle at that particular piece of the graph. So if we connect all of these points, starting at the open point at negative 6, we would see that particular piece of the graph. And it's just going to keep going and going and going because as those x's are smaller than negative 6, they continue to have y values that are actually at 0. Okay, so for the next piece of the graph, let's graph some of those points. I had negative 6, 12. So that would be up there. I had negative 3, 6. That would be about right there. We had negative 1, 2. And then we see that there should be an open circle at 0, 0 because x is approaching that point. And so in this particular case, I didn't do too good of a job of plotting that one. Let me do that again. In this particular case, we see a linear function that comes down and just kind of stops at that open point. And again, we can know it's linear just looking at the fact that it has a single power of x. And then finally, when we graph that final piece, we have a solid point at 0, 0. So what happens there is if you originally had an open, it's going to fill in. And then we have points 1, 1, 2, 4. And what you should start seeing there is a quadratic curve with that particular one. And we know that as well because of the fact that when your power of x is squared, you actually get a curve. So that's what our graph actually looks like. So if you look at our different choices, of course on A, they've got this piece going straight out here, so that part is wrong. And if you look at it's actually kind of a flip of what we've got. When I look at B, so it looks like I'm coming up here, but it looks like, let's see if I count, those are by 2s. So yeah, I've got the open circle here at negative 6 and that line going out. Then it looks like I have the linear part here, and then they join together, but it looks like this piece is going down instead of up, so that would be incorrect there. If I look at this next particular graph, so I see the constant part there, the linear part here, and then it appears that that is going up. So it looks like C is correct. Let's just eliminate D. And so notice on D we have our constant part, but the linear part is going the wrong direction. That's a line that's increased, and the quadratic part is going the wrong direction. So my correct answer there would be C. And then they asked me to use the graph to determine the function's range. And so remember, range refers to the y values. So you're looking at a graph from bottom to top. And as I look, notice there are no y values all down here. So the first y value that I encounter is right here at 0, and I'm touching at 0, so square bracket. And then as I come up, because of the fact that this quadratic is going to continue to go up, 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 up with that arrow, then that means my y values are going to infinity. And we never touch infinity, so we would end off with a parentheses.